Alright, finishing up momentum for right now, anyway. Important things about momentum. P equals momentum. Okay, so that's the symbol that we'll use is lowercase p, momentum. Then we've got the equation, which is momentum is just mass times velocity, where momentum is a vector and velocity is a vector. So that means direction matters, right? The units for momentum, well, what are the units? I don't know, Mr. Scopetus. Plug in what's in the equation. The units for mass, we know are in kilograms, and the units for velocity, we know are in meters per second. So it's mass times velocity, so the units for momentum are a kilogram times a meter per second. And I think that's pretty much it. Momentum is conserved. Alright, so the conservation of momentum is the net momentum before a situation equals the net momentum after. And that just means you're going to take your positive momentums and your negative momentums before and your positive momentums and negative momentums after. How do you get a negative momentum? Well, you remember that momentum is a vector and velocity is a vector. So if you have a negative velocity, that means that negative just means you're moving in the opposite direction. Okay? So if you have momentums going in... Sorry! I just remembered my face was covering up all of that. But I think we're fixed now. Now you can see net momentum before, net momentum after. Alright, so explain on to the next one. Explain your reasonings. Answer yes or no and then explain. Please make sure you are explaining your reasonings sufficiently. So let's see. Is it possible for a single object to be moving and yet have zero kinetic energy? Well, we know the kinetic energy equation equals 1/2 mv squared. So can it be moving and have zero kinetic energy? Well, if we have 0 over here, then either it's got to have 0 mass or 0 velocity. I'm going to put a big no on that. I've got an explanation there. I'm going to try to clean it up a little bit. To have this situation true, you would have to have mass equal 0. But if it doesn't, velocity would have to equal 0. And it doesn't. So you have a single object, which we're assuming to have mass. It's not a massless object. We're not talking about light or anything here. We're talking about a point mass, which for us will be everything. We're not going to deal with massless particles at this point. So, no. You've got to have some kind of mass or some kind of velocity to have any kind of kinetic energy, but if you have 0 kinetic energy, then you've got a mass and velocity. Shoot. Now for your explanation, you're going to just summarize this into words. So something like to have 0 or to have k equals 0. And in your explain, it's okay to use symbols, absolutely, to shorten up your writing or your keystrokes. To have k equals 0, you'd need 0 mass or 0 velocity. What have I done? Or v equals 0. Yeah. Alright, so part B. Is it possible for a system of objects to all be moving, and yet the system has a total kinetic energy? So if we're talking about a system, we're talking about multiple objects. So that means K1 plus K2 plus K3, and so on. However many objects we're dealing with in the system. So if there is k1 plus k2 plus k3. If k equals 1/2 mv squared, as we see right here, then you would need to have negative kinetic energies. And we can't have negative kinetic energies. So no, you would need negative kinetic energies. And remember, negative kinetic energy means that you have a negative mass because V is squared, so V is always going to be positive. And we're not going to ever have a negative mass. We can't. Okay. So what I mean by you would need a negative K, let's say K2 minus K2 equals 0. You would need a situation like that, and we can't have that. No negative kinetic energies. Okay. Onto the 3C, whatever. It is possible for a single object to be moving and yet have 0 momentum. Well, our momentum equation is P equals mv. Moving implies some velocity. So if we have a velocity of 3, can we get momentum to 0? No. You would need to have a 0 mass. If it is moving, it has momentum, is where I would go with this sentence. There is. Don't use the word it. It's just sloppy. And when it comes to explaining, it's not very specific. And with physics, we need to be specific. If it is moving. So how about if object is moving? Come on. If the object is moving, there is momentum. Is it possible for a system of objects to be moving, and yet the system has a total momentum of 0? 0 total momentum. So that would mean we have multiple objects, P1 plus P2 plus P3. All of our objects and the net momentum equals 0. Well, to have this situation, we would need to have a negative momentum at some point, somehow, some way. Can we have negative momentum? Yes. Of course we can have negative momentum. Negative momentum means a negative velocity. Okay.